Testing, testing, 1, 2, 3. All right.
Good evening, sir.
All right. Good evening, everyone.
Good
Good
evening.
evening, Mr. Ray.
If you can hear me, good evening, of course. All right. So today, writing down. So I'll just be writing down your names. And okay. So Norma, good evening to you. And Jacob, good evening to you as well.
Good evening.
Dorcas, good evening. Salvador, good evening. And Susanna, good evening. And Latavia,
Good evening, sir.
good evening. And Clemente, good evening. And
Good
William.
evening, Mr.
Hey, Mr. Ray, how you doing?
I'm fine, thanks. Good evening, you guys. Everyone that's here tonight so far. My daughter's up here asking me questions. Sorry, distracted me. So yeah, good evening. And we want to get straight to it because with the change of plans, if you weren't here on Tuesday, I was letting you know I was thinking the class ended with the rest of my classes. The rest of my classes end December 16th, and by the rest of the classes, the non-math classes. But for some reason, my math classes end earlier than my science and social studies class. So it actually ends next week. So next week, if you did not know, is the last day of class for mathematics. If you are in social studies or science, they actually continue one more week. And that's mainly because they do the two-term system from my—
Mr. Ray,
Yes,
when you say last week, it's that next Tuesday or next
Thursday is the last class.
So the
10th.
Thursday. So we finished the week with you.
Yes.
Tuesday and Thursday. Okay.
Tuesday and Thursday we'll be in class. So next week, Thursday, would be the last class of mathematics.
Yes, sir. Thank you.
You're welcome. All right. And let's see. So yeah, of course, that kind of squashes my plan a bit. I have to rush a bit more. I was hoping to have one more week to finish off everything. All right, so let's go ahead and begin. And just trying to share. Oh, first things first, of course, I am pretty sure there could be some questions about the homework. And so remember, if you were able to attempt the homework, it's on page 102 in the workbook. And just bear with me real fast. I'm just gonna get some water and I'll be right back. So just make sure you're on page 102 in the workbook so that we can start soon when I come back. Okie dokie, is everybody in there on that same page?
Yes, sir.
All right, great.
Yes, sir.
All right, so any questions from that section if you were able to start it?
Can you do number 17?
Okay, number 17. Okay, so everything from 16 onwards and number 9 should have been in the next section. So I was going to save those for last, depending on how you guys understand anything from 1 through 15, excluding 9. So the other class was having some trouble, but I think you guys would handle it much better based off of what I've been seeing each night. But you would have, I didn't realize it till I opened the book, but I didn't realize it till this morning when the other class was asking questions that number 16 onwards was asking stuff that's in the next section. And so you might have been thrown off from that, but it's not too difficult. But let's just see how we do. We faced with 1 to 15. With the other class, I ended up just skipping graphing altogether. I'm hoping that we can finish off some of the graphing tonight. And I'm picking up my echo somewhere, so I'm just going to mute everyone. All right. So Latavia, just keep that in mind. Once we're finished, just remind me, and I can show you how to do that one at the end
I will, thank you.
of the homework. You're welcome. All right, any other questions from numbers 1 through 15?
Mr. Ray, I have I was having a hard time with all of those. So if you can pick 1 or 2 to go over, that would be great. Anyone from 1 to 7, or even to the
All right,
rest of them.
we could just go in order, and I just did
Okay.
that with the other class. Actually, I skipped 1 and 2 first, and I started with 3 with them.
That sounds good.
All right, so hopefully you guys have been practicing and studying, because if you do, what you're going to see is like a puzzle coming together. But if not, and I know there's a lot of issues that can pop up, but just note that it's not you. It's not nothing that is preventing you. It's just time. So never think that you can't do it. It just could be, you know, you got a busy life, and so therefore you can't really get to it like you want to. And if you had the free time, you would do well. But don't ever think that it's beyond you. All right, let's go ahead and begin. Number 3, that's on page 103 in the workbook. And the first question asks is, which ordered pair is a solution of y equals to x squared? All right, any ideas of how to tackle that first before I go over anything else? Remember, an ordered pair is literally the x, y, right? Because they are in order and it's a pair. So that's our ordered pair, x, y. And then we have the equation y equals to half times x. So what do you think we could do if we don't know which one to choose? What could we do here to figure out? And
Substitute?
substitute. Do you remember that? Well done. Substitute. Right, so we're going to substitute the values that are here, 4, 8, 1, 3. And how would we know which one is correct? What has to happen in order for us to know which one is the correct answer?
It has to go into each other evenly.
Say that one more time.
It has to go into each other evenly.
Yeah, it basically has to equal each other, basically, yeah. So that's what we want to see. If the left side equals the right side, when we substitute in there, then we know which one's correct. And remember, this is the x. All of these ones here are the x values, and all of these ones here are called the y values.
Nice.
Yep, there you go, y values. All right, so let's go and start with a. If I was to substitute a into this equation, what is my value for y?
8.
8.
8.
And what is the value for x?
4.
4.
4. And we want to see, is this true? What's half times 4?
2.
2. Is that true? No, that is not true. 8 is not equal to 2. So we know the first selection is not our answer. All right, then we can try B. That was A. We can try B now. B says 1, 3. So what is my y value?
3.
3. So we put 3 in for y. And then what is my x value?
1.
1. And what is a half times 1?
Half.
A half. Is 3 equal to a half?
No.
No, so that's not true either. B cannot be our answer. How about C?
I think C will be it.
Okay, I hear a maybe, so we try. What's our Y value for C?
2.
2,
2. What's our X value?
4,
4. And what's half times 4?
2.
2.
2. Is that correct? Yes, that is. So that means our answer is C.
Yep.
All right, remember I've said a few times, if all else fails and if they give you a point or X or Y equals something, substitute. If you don't know how to solve it, but they show you what the solution could be, and you don't know how to work it out, just substitute back in. Now, in this scenario, you would have had to do it anyway. This one, you had to actually substitute anyhow. So, all right, any questions about that?
No, sir.
No need to try D, and D wouldn't work anyway. Yeah, D would not work. So we know that we have the correct answer. All right, how about number 4? It says, what is the missing Y value if 2y is a solution of negative x equals y plus 2? Right, you have kind of 2 options, but the first option is the easiest. We have 2 and we have y. What is our x value in this coordinate pair? So remember, we have an ordered pair, x, y. What is x equal to in this situation? What is our x value? And don't overthink, it's like literally right in front of you.
1.
2.
2. X is 2, right? X, y. That's the
Right.
ordered pair. So they're telling you that x is equal to what?
2.
X is equal to 2. Does everyone see that?
Yes.
Right? The ordered pair is x, y. They have 2 there for the x. So what is the x equal to? 2. Now that's going to help us out because they want us to solve for this equation, negative x equals to y plus 1. But do we know what x is equal to?
No.
I thought I heard a no. If I did hear a no,
2.
yes, 2, right? X is 2. So what would I write in place of this equation? What can I substitute in there? How would I write it?
Negative 2.
Negative 2 equals to y plus 1. That's correct. And then what can I do if I'm looking for y?
Substitute.
Well, you could substitute, and you would have to do each one, but there's an easier way to do this one. All else fails, substitute. But do you remember the easier way to get this done? We're solving for y. We're looking for y. How do we do that?
Oh, we do the numbers together and put a y by itself.
Okay, I heard 2 people, but I heard 1 clear, of course. You're collecting the like terms, and so we want the y by itself. And remember, keep the variable that you want positive. And since it's already positive, what should I move?
2 to negative 2 over 2.
Well, I want this one to stay here because it's a positive y.
Okay, so you're gonna move it.
You move the 1?
Move the 1, yeah? See, if I move that 1 over, y it's by itself.
Right.
And how do I move the 1 over?
Negative.
Negative 1, right? Subtract the 1, the opposite operation with the same number. And what we do to one side of the equation, do to the other. That's the whole, what was just stated from, I think, Latavia, put the numbers together. So those cancel, and we have negative 2 subtract 1, and what does that equal?
Negative 3.
Negative 3, that's correct, well done. And so y should equal to?
Negative 3.
And which answer choice would that be for number
That's
4?
A.
A. All right, that looked weird. I tried to circle that and made a D. A. All right, so any questions about that?
No, sir.
All right, so how about number 5? Oops, what is happening here? My computer must be glitching. Number 5. Number 5 is very similar. It says, what is the missing X value now? And they give you, what is going on here? They give you X -3. So do we know our X value based off of that coordinate point?
No, sir.
No, but do we know our Y value?
Yes.
Yes,
What is our Y value?
-3.
-3. So when they give us this equation, 2x plus 2y equals to -8, what could I do at least first if I know one of my variables?
You're
Substitute
Replace
replace it.
the Y with the -3.
-3.
That's correct. We're going to substitute. What is, somebody have control of my computer? This is weird. All right, there we go. 2x plus, we're going to substitute y in, -3 in for y. And that can allow us to solve because now we only have one variable. So we have here 2x. And what's 2 times -3 give us?
-6.
-6 equals to -8. All right, and then what do we do?
Move the -6 over.
Okay, and how do we do that?
Add
Right, add 6
on 8, so we can, on the 6, but -6, so we can eliminate it and then add it on the other side.
That's correct. What we do to one side of the equation, do to the other side. And so what's -8 plus 6?
Positive -2.
-2, that's correct. And then the last step,
We divide the 2. We divide the 2, and then we do the same thing to the other side.
all right, divide both sides by 2. And so x will be equal to, what's -2 divided by +2?
-1.
-1. And which answer choice would that be?
C.
B.
C. It should be C. All right, and so that's how you would do it. Now, you could have substituted the other values in, but in this scenario, you should have this mastered by now to be able to, a simple equation, once you substitute it in there, to continue working through it. All right, number 7 is pretty similar, and I'm gonna allow you guys, sorry, number 6. Number 6 is a little different.
Hi,
But
Mr. Ray.
good day, George, how you doing?
Fine, I'm just back from work now.
All right, we are on page 103 in this workbook.
103, okay.
103. Sounded like you had said back 143. All right, number 6. Number 6, similar. It says the graph of the equation y equals to 4 subtract 3x will pass through the point on the coordinate grid, right? And so they give you a selection choice here. They have A is 1, -1. B, they gave you 4, 8. C, they gave you 3, 1. And the last point there, D, 2, -2. All right, and remember to pass through a point, basically it's saying you are trying to see which point, let's say it's a couple of points there, they have 4 points. So let's say you got a point here, a point there. This is not drawn to scale, just random stuff. All right, let's say those are our 4 points. Just an example, this is not the real drawing, so don't copy this up. All right, they're saying only one line passes through, only one point is actually on the line, or the line only passes through one point. And you're trying to find out which point is that, which point is on the line. Now remember, we've learned before that when we were doing tables, remember we had the table x, y, and we had coordinate points. So for example, if x was 1, y -1, x was 4, y 8, etc. And those same points are the points that we graph either on the line or just randomly around. And so what they're trying to ask you to do is to figure out which one of the points over there, over here, right, all these different points, which one of these points would satisfy this equation, which would prove that the point is on the line. Does that make sense? It's all interconnected. So hopefully through your studies, you're starting to see the connection. If not, hopefully you see it as we move on. And let's see if that works. So in this scenario, what could we do? We know this is X and we know these are Y's. All of those are X values and all of these are Y values. So if we know what our X and Y is and we have an equation, what could we do?
Substitute.
Can we substitute now?
You can substitute again. Not every question will be substitute, but a good bit of questions will rely on the concept of substitution. So what's my Y value? Try to do A
1.
first.
1.
Close.
Minus 1, my bad.
Yes, so -1 is equal to 4 minus 3 times
Positive 1.
+1, right? We're just taking the values. Remember the coordinate pair, the order pair, the coordinate point. There's different names for it, but those can be substituted into the equation. The equation represents the line, and the point represents some random point that could be on the line. All right, so keep that in mind. So we're trying to see, is this point on the line? So we have -1 equals to 4 minus 3. What does 4 subtract 3 give us?
1.
1.
Is this a true statement? Can -1 equal to 1?
No.
No, that is not a true statement. So this is not our answer. Hopefully that makes sense. And then we try B. B is the point 4,8. What is our Y value in 4,8?
8.
8. And then here we have 4 subtract 3x, but what are we going to put in for x?
4.
4.
4. And then we simplify. 8 is equal to 4 subtract, what's 3 times 4?
12.
12, and what's 4 subtract 12?
8.
8.
Close.
Oh, 4 subtract 12, it's 8.
Close.
Oh, -8, my bad.
-8. And technically it's not close. It's close in terms of appearance, but in reality it's very far apart. Because -8 is here, and then you got 0, and then +8. And that's a distance of 16 units. And so if that was money, $16. If that was -80 and +80, then there'll be a difference of $160, right? It's a big difference. So we have to be really, really careful with those negatives. Dorcas, I see your hand up. Dorcas, did you have a question? All right, so B is not equal to each other, so we can cancel out the B. And then we can try C, and we can do the same thing. So what would we do to see if C was an answer?
So we put 1 equals 4 minus 3 times 3.
Right, and then you want to see if that's true. So we have 1 is equal to 4 minus, what's 3 times 3?
9. Negative
9.
9.
And we can see already this is not going to equal because 4 subtract 9. If I had $4, someone owed me $9, or sorry, I owed someone $9 and I paid them 4. How much they're going to say I still owe them?
-5.
-5. So that's not equal. So you can conclude now that D must be the correct answer because all the rest are wrong. And so we'll try D, and we should have
The Y is 2. And
Say it
that's,
again.
the Y is 2.
Close. The Y is
Oh, my bad. -2.
-2. Right. So, and one thing, this is very important. Always try to label your X and Y before you start. It's very easy to mix them up.
4.
We have -2 is equal to
4 minus 3
It's 3.
times 2.
times 2. All right. So we have -2 is equal to 4. Subtract what's 3 times 2?
-6.
6. And then if we put those two together, 4 and -6 are going to give us
-2.
-2. Is that correct?
Yes.
Yes, that's a true statement. And if you were confident with your other work and you didn't even have to do it, you would have just said D is the answer. But we checked just to make sure, and D was the answer, and that's how you can approach it. Now remember, if all else fails and you see either a coordinate point or just a number and the action is that a solution, or they have x equals 3 and you don't know how to work it out, you could just substitute the values in there to see which one makes a true statement. All right, so that's one way to look at it. So with that, can you guys try to do number 7 for me? Number 7 says, what is the missing x value if x1 is a solution of 2x minus y equals to 5? And this one is very similar to number 5.
7, 2, 6.
Mr. Ray?
Yes.
Yeah, I'm driving right now, so I can't really participate in the
Oh,
work.
okay.
Yeah.
I see why you was having trouble then.
Yeah.
How
Thank you.
How close are you to being home?
I'm almost home. I'm gonna be home in about 5 to 6 minutes.
Oh, okay, so you shouldn't miss too much. Just
Yeah.
remember, keep your eyes on the road, though.
Okay, that's why I'm trying to
Yeah,
to let
just you can listen and just let the words seep in, but
okay, okay.
keep your eyes on the road.
Okay, thank you.
You're welcome. Thank you for letting me know. All right, I see an answer in the chat. Okay, and Latavia, you said that privately. That's correct. All right, I think everyone should at least have this part here. So I'm just about to start it. Remember again for number 7, and I see another answer coming in. And William, that's correct as well. All right, so this one here, it gave us the point x1, and then it told us that it's a solution of 2x subtract y equals to 5. All right, so with that, what is our x value? We don't know, but do we know our y value?
Yes, the y value is 1.
5.
Yes, the y value is 1, which means we can substitute the 1 into the equation. And because we have one of them, when we do that, it's going to allow us to find the missing variable. So far you've seen we can either substitute one of the pair or both of the pairs. And so you see that in number 6, we had to put both of the pair in. We put both of them into the equation to see if it's true. But for numbers 3 to 5 and number 7, we're using one of them to find the other. And that's why they're also called corresponding values or corresponding pair, because they correspond to each other. And back. All right, so we have 2x subtract y, and as was stated, that y should become a 1. All right, and if we were to go ahead and solve that, that's correct, Marisol. How would we solve this equation?
What did you say, sir? Sorry.
How would we solve this equation? 2x subtract 1 equals to 5.
Oh, so you put the two, you try to isolate the numbers by itself.
Right?
You can, a positive 1 over the negative, under the negative 1, and a positive 1 under the negative 5, under 5, sorry.
Right, that's correct, right? What you do to one side, do to the other. And that's
So
going to
you
give us
do
2x
x
equals to
equals
6. And then what?
And then you do the same thing here. You then
Right.
select
So,
x and the
and what
total.
was that? What is that thing that we have to do?
Substitutes.
Divide.
Okay, you could do substitutions and see which one works. 2 times -3, 2 times 2, etc. You could do that. That's fine if you wanted to try that. But if you were to solve it completely through, I heard somebody say to divide by 2, and that's correct if you wanted to solve right down. And what you do to one side of the equation, you do to the other. And this allows you to get right to the answer. So x is equal to 6 divided by 2, which would be
3.
3, positive 3. So be careful because they had a negative there. And positive 3 is which answer selection?
C.
C.
Okay, hopefully you're starting to see the connections. And if you review this with the stuff that we did in tables, remember the coordinate points are what we put into the table. And the results of what we get in the table is because we substitute it into the equation. Do you guys remember that? We had the table of values and we had the equation, and we were putting points in, and that gave us the coordinates, which we can plot on a graph and then draw a line. And so sometimes they're asking you to go forwards and backwards, start in the middle and go backwards, etc. The testing, how much do you know about what we've been doing? And so you're going to get a variety of questions to see, do you understand that the order pair x, y is directly connected with the equation? Okay, thank you, Sergio, for updating me there. And so that's the type of things that they're going to ask. And as you see, they're also going to connect it to the graphs. All right, we're going to skip over these graphs for right now and go over to number 10. We're not going to do 11. I'll leave that one out. But number 10 takes a little bit of time. And so on page 104, number 10, it asks which point is the solution of each pair of equations. And if you look at the very top of that section in that big box, the little bluish, purplish color box or lilac, whatever color that is. Anyhow, now my mind's like, what color is that? Anyway, in that box, it says drag and drop. And so you want to click, if it was on a computer, you would click, let's say, -4, 0, and you would drag it to the correct solution, to the correct equations. And so here, we're just going to try to figure out which one is correct. And this one's different, though. They want to see which point satisfies both of the equations, right? Not just one. It has to satisfy both. So you have two options. You can either start with the points first or the equations. I think it's easier just to, it doesn't really matter, but I'm going to start off with the point. And I'm going to choose the first point, -4, 0, and substitute it into the first card with the first 2 ones to see if it's true. And so the first 2 equations are y equals to half x plus 2. And then we'll try it with y equals to 3/2x subtract 2. All right, so we're going to do that one first. If it works for both of them, according to the question, it needs it for both, then I can say it's correct. So we don't know yet. Remember, this is your x value. This one's your y. Okay, so let's go ahead and do this. How would I write this in now that I know what my x and y's are?
Going to say 0 equal to a half, open bracket, -4 plus 2.
Okay, that's correct how to write it in. And now we want to see if it makes a true statement. So what's half of -4?
-2.
-2, and -2 plus 2 is 0. Now be careful because some people would jump the gun, but we still need to do the next one. So we know it works for the first equation, but now we need to see, does it work for the second equation? Because they want it for both.
Mr. Ray, let us go through. Let me understand it. I don't get to. Okay, we substitute the 4 minus 4 and 0 for x and y.
Right.
Okay.
Okay, and then we do it again for the second equation. So how would we write the second equation out?
Be 0 equal to 3/2, open brackets, -4 plus 2.
Plus
No,
2 or minus 2, right?
-2, sorry.
Okay. I wrote -2 in here. All right, so now we can see if this is true. And so we have, hopefully you guys remember how to do fractions. You have 2 ways to multiply that. You can say 3/2 times -4/1, because any number can be written as a fraction over 1 and multiply straight across to get -12/2 and then simplify. Or you can cancel. With the cancellation method, you cross cancel and you say -4 divided by 2. The 2 will cancel out completely and you're left with just -2. And and then you can multiply straight across. Either way, it gives you the same answer of -6. All right, we had learned that a while back at the very beginning of class, if you were here at that time. So that becomes -6 minus 2. And will that ever give you 0?
No.
Sir.
No. So this one is not correct. This is wrong. Those two are not equal. And therefore, -4, 0 does not work for those two pairs. So that means we're going to try the next one, which means we can try -4, 0 with the next pair. Now, there is a faster way to do this, but I just think it's faster, but it requires learning a new topic. And I'm not sure if that's going to be feasible right now. And so this is the push comes to shove mode. All right, so we have our X and Y. We're using the same one. And now we're doing the second column of equations, which is Y equals to 3/2, X subtract 2. But what's interesting, this is the same equation as this one here. And did it work with that point that we did?
No.
No. So, and that's why you want to be observant. Being observant can save you a lot of time. So we already know this one doesn't work. It's not equal to -8. So that means this point doesn't work for the second column either. So if it doesn't work for the second column, what does -4, 0 have to work for?
The third?
The third column, right? You could just use logic. Now, we can work it out so you can see it, but if it was me, I would just click and drag -4, 0 over, because it's clear that's the point that it matches over to. Do you guys get what I mean? That -4, 0 matches with the third column of, or the third pair of equations,
Yes.
right? We can
Yes, sir.
see that because it didn't work with the first two, and that could save us a lot of time. Does anyone need me to show that it works, or do you get what I'm saying?
We leave
Mhm.
Did I hear show it, or no? It's just keep on going?
it. Keep on going.
All right, so if we keep on going, we now know that -4, 0 matches with the last column, right? And so that means we now just need to check 4, 4, and 0, -2 with the other two. So because I know that, I'm going to go ahead and just erase this. And I don't have a lot of space, but you guys should. And now we'll use the second point, -4, 4. Sorry, 4, 4. Sorry, +4. So I can use +4, 4, and see does +4 work for either one of those. And the same thing, I can use my logic. If it fails for the second one, it obviously works for the first one. And vice versa. If it fails for the first one, then it obviously works for the second. All right, as long as you're doing good math. So we have 4, 4 there, and I meant to write that in red. But anyhow, we have Y is equal to, and do you guys want to do the first column or the second column?
To the first column.
All right, so we do the first column again. We have ½ X plus 2, and I'll change it to blue. So what is our Y value? How would we write this out?
Or
Say 4.
one, two.
Or
4 equals to ½
Open bracket 4
times 0.
plus 2.
plus 2. All right, so we have here 4, and ½ times 4 is 2, and 2 plus 2 is 4. So it looks like this might work, but we still have to check the second one. So we do the second one, and that's what, oops, that's Y is equal to 3/2, X subtract 2, and I'm substituting the 4 in, and similarly, we have Y is 4, we have X is 4, minus 2. We can cross cancel. 4 divided by 2 is 2, and 2 times 3 is 6, and what's 6 minus 2?
4.
4. So that means this works. The point 4, 4 matches to the first column. The 4, 4 matches to the first column, and -4, 0 matches to the last column. Where would 0, -2 go to?
Middle.
Middle column. And that way you don't have to do them all. Now, like I said, there is a faster way to do it, but I would have to teach you. It's not that hard, but it actually connects with 16. I think you guys can handle it. Just trying to ponder, like, should I do that? So I'm gonna try it and see if you guys understand it. You understand it. If you don't, you don't. And I'm gonna connect it to 16 as well. So here goes nothing. Let me know if it's confusing, but I think you guys might get it. All right, so we're still on number 10. Now, I'm really jumping the gun, so put your thinking caps on. I really think you guys can get it. When you have two pairs of equations like that, where one point is on both lines, what is the only way that one point can touch two lines? What has to happen? And you can even look at number 16 to help you. Can two lines ever touch at one point in any format, or does it have to be a certain way those lines are? Can these lines like this, will these lines ever touch?
No.
No.
No. So can these two lines have any point in common?
No.
Can these lines have a point in common?
Yes.
Yes.
Yes. And that's what we call the intersection. The point that is in common is the point that will work for both equations. Because remember, this represents an equation, and this one represents an equation. So I'll say equation 1 and equation 2. So in number 10, if you can picture this, y equals to half x plus 2 could be equation 1, and y equals to 3x minus 2 could be equation 2. And the point where they touch in the middle is the point that works for both of them. Does that make sense?
Yeah.
Yes, sir.
Yeah.
If I had a random point, let's say negative 4, 0 did not work for the first column. Negative 4, 0 could look like, actually it worked for one of them. Negative 4, 0 could be like that. It's on one equation, but it didn't work for the other equation. Did that make sense?
Yes.
And then when we did the other point, that point worked for one equation, but it didn't work for the other equation. For the point to work on both equations, it has to satisfy both equations, because then it means graphically that the points are intersecting, or the line is crossing, and it's crossing at the same point, and therefore the point will work on both lines. Does that make sense?
Yes, sir.
Yes.
So when you look at number 16, and it goes also with your question, Latavia, I think it was 17 or 18 you'd asked.
Yes,
The
17.
same thing applies. They were asking you to see, can you find out the point that works for both? Or they're asking it from a graphical standpoint, whereas the number 10 is asking from the equation standpoint.
Okay.
Does that make sense, everyone?
Sort of, kind of.
Sort of, kind of. All right, so that's basic, and since it sort of kind of does, I'm just going to continue with the rest. Now, I'm still trying to decide, should I show you the alternate way of doing number 10? I'm going to try it out, and if it's a bit confusing, remember, if all else fails, substitute.
Okay, sir.
All right, so if these two equations are sharing a same point, that means at this point, these equations must be equal. Does that make sense?
Yes.
Right? If they're touching at the same point, then it must be equal. If I'm touching someone's hand, then at that point we're equal in that little point right there. And so that means if we go back to number 10, the very first column, we look at number 10 and we had y equals to half x plus 2, and we had y equals to 3 over 2x minus 2. If these two things are equal at that one point, then we can set them equal to each other. Does that make sense?
Okay.
Because they touch at the same point, because they have a point in common, that means the two equations must be equal at that point. And if they're equal at that point, then mathematically I can set them equal to each other. And if they are, then I could just go ahead and solve. And remember, that's why we were learning how to solve expressions on either side. We were building up for this type of concept where you can solve an equation faster than just trying to do that. And actually, it may sound like a lot, but this way is actually really fast. And so if I was to solve this, we've practiced solving these before. We would subtract the half x, and don't think too hard here. When you have a whole number and a fraction, that's actually really easy. And if I had $3 and I spent 50 cents, how much would I have left?
250.
250, or 2 halves, right? So that's 2 half x minus 2. And then I can add 2 on both sides. And the 2's will cancel, so I have 4 equals to 2 halves. And, you can either think of it as 2.5 if that helps, right? So 2.5x. And then divide both sides by 2.5. And if you do there, 4 divided by 2.5, that didn't work out right. Let me make sure I did that correctly. Half x plus 2, 3x minus, I wrote 3. Really insane person. So my bad, if you were copying that, I wrote 3x, and that should have said 3 over 2x.
Because I was wondering, right, how come you put just 3?
Yeah, if you see that, let me know, because, I'm a bit tired. I stayed up late last night. Wasn't a smart idea. So anyway, 3 over 2, this actually makes it easier. So I'm kind of glad it was another fraction. Forgive me. But yeah, if you see me going off, don't be afraid to say, Mr. Ray, that is wrong. I actually appreciate that. When I was in high school, I used to get bonus points if somebody corrected me. I do not mind being corrected. It shows that you're following along. All right, so 3 over 2, subtract 2 over 2, right? You just subtract the numerators, and that would be 2 over 2, which is 1. So we have 2 equals to 1x, which is just x minus 2. And we add 2 on both sides. And there we would get 4x is equal to 4. All right, and then with that x equals to 4, we can substitute it back in because we have one of the values. But because we have x equals 4, we could just look there which one has x as 4.
Second one.
The second one, and I didn't have to go any further. I could see right there, just from doing that, that's my answer.
That's pretty cool.
Now, it gets even cooler if you know how to use your calculator, but there's a lot of steps to that as well. But that's something that, we didn't get to, but the book just decides to throw it at you guys. I didn't expect it until I opened it up this morning and saw it, because I didn't really look through it when I assigned the work. But that's how you would do it if you really wanted. Now, once again, that's the logic behind it. The logic is that if the point works for both equations, then both equations must be touching at one point. That's what we call an intersection. If the equations are touching at that one point, that means that at that point the equations are equal. And if the equations are equal, I can set them equal to each other, and then I can solve like we've done in the past, and I can find out what that variable is. And if I needed to find out the y, because I have the x value, I can substitute it back into the equation to find the y. Now notice you should get a 4, and it didn't matter which one you substituted back in. If you did the first one, y equals to half times 4, we already did that, but that's going to be y equals to 2 plus 2, and 2 plus 2 is 4. And you see that you get that y equals 4, just like you do in the point that's there. I know that's a lot of information, but I had a feeling that you guys could at least handle it a bit. So with that, we might as well do number 16. So let's try number 16. Any questions though with what I just did?
No, sir, I'm good.
Did it make any sense, or did it go over your heads? Be honest. If you said it went over your heads, just say, yeah, I didn't understand it. But if you did, let me know if you did.
It was okay for me.
Okay. Anyone else? Okay, only one person? My bad. I was hoping you guys would get it. But let's go on. Number 16 might actually help you out some more. Actually, this one, surprised they have this here already. All right, so for number 16, you could do it the way that I just did it, but if that was a bit difficult, you may not want to try it. But we can use the same logic. And so if you look at A, notice again, there are two equations, very similar to number 10 or number 16. And they are telling you that the two equations have a point that's in common, right? How do we know they have a point in common? Because what's happening between the lines?
They meet at somewhere.
They're meeting at a point. So where are they meeting at point A? How would we write that point out?
Point would be 1.
Positive 1.
That's positive 1, but what's positive 1? The x or the y?
X.
X.
X, right? So basically, this is very similar to number 10. We know that for A, that picture is 1, 0, right? So your x and your y. What is B? Where are they intersecting at B?
Positive 1 Y.
1 on the Y axis.
And what is it for the x-axis?
X
0.
0. How about C? Where are they intersecting?
Negative 1.
Negative 1.
Y.
Y is negative 1, and what is the x value?
0.
0. And then for D, what are they intersecting at?
Negative 1.
Negative 1 on the X
Negative
axis.
1 on the which axis?
The X axis.
And how about the y-axis?
0.
Close.
1.
Negative 1. Negative 1.
Negative 1 as
Yeah,
well.
negative 1, sorry.
All right, so here, although they gave it to you as a picture, you could write down the points and then do the same thing. It means that you have to find the value that will work for both of these. And so you can substitute them in and see which one works. And it wouldn't take that long because these are very easy values. They're not fractions or anything. And if they were fractions, you have a calculator. So you can substitute that in, 2 times 1. And remember, it has to work for both of them. Your y value is going to be what?
0.
0. And so here, 2 minus 0, does that equal 2? Yes, it does.
Yes.
If it works for the second one, A is our answer. So what is our y value for the second one? 0. What is our x value? Negative 1. Does negative 1 plus 1 give us 0?
Yes.
It does. So that's our answer, A. Do you see how they connected your understanding of points, your understanding of logic, and also your understanding of substitution? So once again, with this question, we're using the logic that if a point works for both equations, then graphically those graphs must be intersecting. That's the only place where both of them will share the same point. If they share the same point, then that point, when it substitutes into the equation, must work for both of them. If that point works for both equations, then that's the correct answer. If the point only works for one, that means that the point is only on one line and not on both lines. Is that starting to make more sense?
Yes.
All right, let's try, was it number 17 or 18? I think they're all,
17. 17.
I think, yeah, all 3 of them are for the same question. All right, so number 17, page 105. Very similar concept from what I can see. I haven't read it yet. All right, so it says Rachel runs a small business. She produces and sells homemade fudge. The following graph shows Rachel's total revenue and total expenses based on the number of pounds of fudge sold. Right, so we see that there. Just get an idea of how it works. They're missing the x-axis, y-axis. But anyway, down bottom, they show you the pounds of fudge. And then on the top, they're showing you your revenue and expenses, or basically the money. So on the y-axis, that represents money. So we see $50 and stuff. That's what we're seeing. So one equation just represents the expenses. Which one is the expenses? That's the one that's going to 150. Which one represents the revenue? Well, that's the one that's going down by 0. Do you guys see that?
Yes.
Right, so those 2 equations show expenses and revenue. So if you wanted to find out how much her expenses are, what you do is you look at a number, let's say 6 pounds of fudge, and you go up to where 6 pounds of fudge meets, that coordinate point says for every 6 pounds of fudge, she spends about $160. Does that make sense?
Well, let me see.
Let me see if I can.
6 pounds of fudge is $100 and something.
For expenses, I'm gonna try to sketch this up real fast. It's not gonna look exactly the same, but I'm gonna do my best to
So,
make.
Okay,
Mr. Ray, is that where they cross, right?
Well, no, I was looking somewhere else. Where they cross is where her expenses and her revenue are gonna make her basically break even.
Right, so.
What this chart
at the-
does, if you were like the manager of a company, you can use this chart to predict how much things you need to sell so that you can break even. And it makes it visual so you can quickly see it without having to do many calculations. All right, so if I was to try to sketch this out, I'm gonna make the pink line her revenue. So her revenue looks something like that. And then her expenses, I'm gonna make that a black line. Her expenses look something like that, right? So black line is expenses. So just put EXP, and then her pink line is her rev, right? So for instance, if I had 6, right, that represents 6 pounds of fudge. If I wanted to see how much 6 pounds of fudge would cost me, what my expenses would be, I'll go up to see where it meets and see where it meets on this side. This side represents dollars, right? And over here, if you try to mess that up, it looks about 160. So basically, for every 6 pounds of fudge, it's going to cost me $160. Does that make sense?
Okay,
Yes, sir.
yes.
And then for every 6 pounds of fudge, if I see where it touches the revenue line, and I go over, that looks like it's 675. So that means for every 6 pounds of fudge, my revenue would be $75. So from this graph, do I want to sell 6 pounds of fudge a day?
No,
No, I'd be in the hole. So where would I actually break even? That if I sell a certain amount of fudge, that I'll just
15,
at what range?
15?
Yeah,
15?
around 15.
15.
Yeah, around 15. If you match that up, you see that the expenses and the revenue are the exact same. And how much would that be? How much would I spend and how much would I make? Approximately.
Approximately 160.
160.
Yeah, about
160 and
160,
15.
170. It looks like it's halfway there, so probably 175.
Right.
So about $175. So that means if I sell 15 pounds of fudge, I'm going to spend up to $175, but I make $175. I'm breaking even. It's not really good. So from this chart, you can see how much fudge you want to sell a day. Anything over 15 pounds of fudge will give you a profit. Does that make sense?
Yeah.
Yes, sir.
yes,
All right, so now that you understand how the chart works, and remember this point here is the point that will work for both of them. So basically 15, 175 represents this same concept you saw for number 16. It basically says if you were to substitute this into both equations, it will be true. All right, so number 17 now, should have erased all of this stuff. Okay, so number 17 says if the revenue line passes through the point 448, what is the equation of the revenue line? Well, we didn't learn how to do that. Sorry, they give it to you. What am I talking about? Okay, so if all else fails, what do you do?
Substitute.
Substitute. So you can substitute 448 into each of those equations
Right.
and see which one is. See which one is what?
It's correct.
Which one is
X.
correct, right? Which one comes out as a true statement? So you can start off with the 12x. You're doing 448. So you guys can try that on your own, and you can see if you could get it before me. You want to substitute in there and see, do I get a true statement? Remember, that's your x and that's your y. So we have 12 times 48, and you could probably see already. What am I doing? Serious. 12 times 4. plus 48. Will that ever give you 0?
No.
No, so A is not the correct answer there. And then we could try 4x minus 5y equals to 0. And we're going to substitute that in there. 4 times, what's my x? 4
Times.
times 48. And we want to see, does that equal to 0? And hopefully you
No.
can see 16 minus that cannot get you to 0.
Nope.
Right, so B is not the answer either. So then we can try 12x minus y. Does that give me to 0?
Yes.
Right. And I hear a yes before I started, and I think it is just by a quick glance.
Yes, sir.
So 12 times 4 minus 48. Yep, that's going to give us 0 because 48 subtract 48 equals 0. And so this is our answer. And so for number 17, if I needed to find the equation that represents my revenue, 12x subtract y equals to 0. All right, does that make sense?
Yes.
Yes,
Yes.
sir.
All right, so now we try number 18. Number 18 says Rachel's startup expenses total $150. What is the equation of the expenses line? So very similar thing. They want you to see what it will be for expenses. So you're going to do the exact same thing.
And then are we going to use the same numbers for 48?
Well, 448 don't lie on the expense line. So what you could do is choose a point that does lie on the line. And they're actually telling you that by showing you that it's 150. What does startup mean?
The startup begin with?
What you begin with. And you can see that on the graph. Where does her line begin if you look on your page? Remember, you always start at 0. So x equals 0. If you go up, where is she starting at?
Minus 50.
At 150, right? And what does the question say? The question says, Rachel startup, what?
Startup equal
It's
150.
150, right? So that means that when she has no pounds of fudge, which is 0, she has $150 in expenses. So before she even starts doing anything, she has $150 that she has to pay. So that's my coordinate point. Now, you could have figured out the 0, or you could have just tried to find it with the 150. That would have took a little bit more work. But if you notice that 150, that the corresponding y value, x value, sorry, is 0, you have your coordinate point. Does everybody see how we got the 0?
Yeah.
The point right there, I want to make it a different color. So look at my red point. That big red dot right there, that's where the 150, that's where she's starting, right? You start right here, that's the starting point. She's starting at 150. The book is telling you she's starting at 150. But what is the value of that point? The x value is 0, and the y value is 150. And it makes sense because if you're starting with expenses at 150 and you haven't sold a single thing, that means you sold 0 pounds of fudge. Does that make sense?
Yes.
Yes.
Yep.
So now that I know what my coordinate point is, I can take that coordinate point and do the exact same thing. If all else fails, substitute, right? You're going to see that a lot. And even in geometry. Geometry is basically just identify the formulas that they give you. They give you the formulas on the test, and then you just substitute the values in. All right, so we're going to do the same thing. You can try to see if you can get it before I do. Remember, this is your x value. That's your y value. And so we have x minus 2y equals to 150. And we can try that on the side. And so you have 0 for your x minus 2 times 150. And you can see that will never get you to 150. So A is not our answer. And let me just write them all out. B was x plus 2y equals to 150. C was 2x subtract y equals to negative 150. And then D is 2x subtract y equals to positive 150. All right, so A clearly did not work. And if you get the answers, you can send in the chat or say it aloud. We have x. I'm not going to write out the equation again. So we have, instead of x, we have 0. plus 2 times 150. Can that ever get you to 150? It's not. It's going to be 300, and automatically you can see that is not our answer. So B is not the answer. And then we try C. Does C work? Well, we have 2 times, what's our X value?
0.
0. Subtract Y, which is 150. And does that equal to negative 150? We have 0 subtract 150. And what is 0 subtract 150?
150.
Negative 150. So is this true?
Yes.
It's a true statement. Our answer, therefore, is C. Does that make sense?
Yes.
No, number 19 is already the question that I already asked, right? Number 19 says the solution set of a revenue equation and an expense equation is called the break-even point, right? Remember I said break-even? I think I used the word break-even. How many pounds of fudge must Rachel sell to reach the break-even point? We already talked about that. How much pounds of fudge?
15.
50. We already did it right here, right? And so you have your answer for number 19. All right, so you guys just learned basically another lesson on top of a lesson. They threw that in there because that actually should be like in lesson 14, I think. Yeah, lesson 14. But they brought it up in this lesson. So it's probably a good thing because you guys seem to have understood it. And then we still need to do the distance formula. All right, let's go ahead now. Any questions with that?
Oh,
I'm just trying to decide, should I show you guys how to do number 9? Did I show you guys how to find the slope?
Yes.
Okay, we're good.
Overrun.
We're going to do number 9 then. Number 9 on page 104. So number 9 on page 104 says, study the grid, then use the drag and drop options to place each order pair or equation in the appropriate box. So that means if you were on the test, that's one of those click and drags. You have to click the box and then drag it into the right spot, right? But we're not clicking and dragging here. We're just going to work it out. Just keep that in mind for whenever you take the test. That's a click and drag action. So with this one, there's a variety of ways to try to solve it, but remember, you want to use what you know. And so far, you can get by a lot of questions if you try it. But remember, any question that's difficult, save it for last, and then come back to it and give it everything that you've got. Everything that you know, throw at the question, but make sure you save it for last. If you try to do hard questions first, you waste time on it. You're going to sit there thinking until you get it. And before you know it, you move on and you don't have enough time. So always work with the questions you know first. Once you answer all the questions that you're comfortable with, then go back to the questions that you're not sure of. Now there's a way to make sure you don't skip it. There's a flag option. You click the flag, and what it does is when you get to the end of the test, it typically will remind you to go back, or you can just go back to your flag option and it'll show you all the questions that you flagged, and then you just work through them that way. And so you save any ones that's difficult for last, and see if you can get it, right? Right, so for this one, the question asks is, what is the equation of each line that makes up a side of the triangle? Now, to read the side of the triangle, you just look at the letters. So I'm gonna try to draw up a little sketch here, just to kind of help you visually. And so that's our XY plane. And then they have, we'll just make them pink. Ooh, that's not pink. So they have one like that, and then they have one coming down like this. Mine is a bit off, but you get the picture. And then they have one coming something like, no, that's not right. That's just completely off. And then the last one does that. Okay, so as close as I can get it. without wasting a lot of time. So then our points, you see that there are point of intersections on each one of these. So we have here P, Q, and R. All right, so we see there P, Q, R. And so when they say side PR, which side do you think represents PR?
Two at the bottom.
Negative X and then negative Y.
So right here you're saying?
Yes.
Okay, yeah, so where they touch, and I think they touch at those points given, -4 and -4. So they're asking you to decide which one goes, which equation goes with which, goodness, that's a tongue twister. They're trying to get you to decide which equation goes with which side. All right, so the way that you can do that is use your common sense. And that way you don't have to worry about real math. Because math is common sense. Everything that we do in math is built off of what we call logic. And so everything's built off of facts. So if you can factually think about something, you can figure it out sometimes without having to do math. So let's try that here because we don't have time to go into the math aspect. So let's look at this equation's slope. Is that a negative slope or a positive slope?
Negative.
Negative. So
Positive.
look at your equations. Which one has a negative slope? Remember, I don't know if I showed this to you. Remember, the slope represents x, and this is a form which we call slope-intercept form. The slope will always be next to the x value. So which number next to the x value is negative?
1/2.
Right, the y equals to -½ x plus -2, right? And so that's your equation. So for, what side is that? So side PR is going to be y equals to -½ x plus 2. And most times they're going to give you enough information so you don't have to do a lot of work. Does that make sense? It has a negative slope. And because this number is negative, remember the slope is always going to be next to the x value.
Mr. Ray, say that again, let me understand, because I'm seeing the P and the R, but let me see, because.
So you see there on the table, it says side PR, side QR,
Okay.
side PQ. They want you to match the equation with each side of the triangle. And so there's a lot of different ways to do it, but we're just trying to look at the easy, logical way, right? So what we want to do is think about what slope is. I tell you guys about negative slopes. You go from left to right. And so you can see that PR has a negative slope. Now, when it's written in this format, where y is by itself, the slope will always be next to the x value. Right? So even if it's written this way, b plus mx, the slope is always written next. Oh, maybe. Sorry, I got a notification popped up. All right, so the slope is always next to the x value. So when you look at PR, you notice that PR has a negative slope. Since it has a negative slope, the only possible answer that can match it would be an equation that has a negative value for the slope, which is -½ x. Does everybody see? Oh, I put +2. So does everybody see how we chose that?
Yes.
Where do we have the half?
They just gave us the half. We didn't choose it, it's just there. That's the choice selection. All right, side QR. So now that we've got one of the easy ones out of the way, you look at side QR. Where's side QR?
QR is on the positive slope.
Positive.
Positive side over here, right?
Mm-hmm.
So we have side QR, and we would need to figure out a way there. You just notice that QR and QP are both positive. So you need a different way to figure this out. And that's by counting the slope. Remember we practiced counting the slope?
So QR will be y.
Say that again.
QR will be y equal to 3/2 x minus 2.
That's very possible. Let me count. That's 1, 2, yep, that's correct, 3/2. If you actually count up, the lines look like that, 1, 2, and then it touches about here. So if you count between those 2 points, remember I said you could choose any points. If you count up, that's 1, 2, 3, and then over 1, 2. And so that means QR has a slope of 3/2. And so which one has 3/2x? That's the second one. And then obviously, the last one, PQ, will be the last equation, which is y equals to half x plus 2. And you could check that one. If you used to count the slope, you see there's a point here that if you went up 1 unit and over 2, it would get you right there. Does everybody see how we use our understanding of to get that?
Yes, sir.
Yes.
All right. Now, what you might want to do is practice these problems again, because if you can get these are those big clincher problems that can really push you over the edge in terms of passing, and not only passing, but passing with a good score. All right, so we're going to go ahead and try. Any questions?
No, sis.
All right. We're going to go ahead now, and you may remember we talked about the distance formula. Where were we? Okay, so if you look on page 102, you will see an example of the distance formula. Remember I said you might have to memorize this. It's not on the distance, sorry, it's not on the formula page. So you might just have to have it memorized in order to do well on this one. But basically, remember, I'm just gonna mute everyone real fast, just picking up some background noise. So remember, to find the distance, we had talked about, I went over the distance formula with you guys, right?
Yes, sir.
Yes. So remember, to find the distance, you're basically taking the larger x value, subtract the smaller x value, and you're squaring it, plus the larger y value, subtract the smaller y value, squaring that, and then taking the square root of everything. And I wonder if they have the formula in your calculator. Anyhow, what you do is, we're going to do number 2 on page 102. And it says a line is drawn from point -3 to -3, to point 2, -2. So this is just an example. So we have the point -3, 3, and the point 2, -2. Then we will see here that we're just finding the length of that line. And in order to find the length, we need to use the points that we're given. Now remember, what you want to do is label them so you don't mix them up. Whichever one that you start calling 1, the other one has to follow with the 1. So if I call this x1, the corresponding y has to be y1. It cannot be y2. You have to be consistent. If you choose this one to be x2, guess what? This one has to be y2. And that's all you do. You're taking the larger y value, and not necessarily the larger, it just means the one that comes next, right? So although the value could be a little bit lower, the point is technically coming after the point. All right, so once you find the values, you just substitute in. And if you've been practicing how to substitute, you can go a long way on the math test. So we substitute x2. Which one is x2 according to what I labeled over here?
-3.
For x2?
Yeah. Oh, sorry. 2, sorry.
Plus,
Okay, 2, yeah. Oh, you could have used that, but I just want to make sure that we're being consistent. So if you did choose -3 for x2, you would have to choose -2 for your x1. And if you do that, all the numbers have to switch up. You have to be consistent. But it's okay if you chose -3, just to let you know.
Okay.
All right, so we have 2. So what I mean is, I just want to be clear, there's no mix up. If Latavia chose -3 to be x2, what would she have to choose this 3 to be? That would have to be y2. Does that make sense?
Yep.
It just has to match. As long as it matches, it doesn't matter which order you choose, as long as each corresponding pair matches in terms of value. So I chose x2 to be 2, and so I'm going to subtract, remember, subtract whatever x1 is, which is -3. So notice I have a double negative there. And then I square that, plus I have y2. Y2 is going to be -2, subtract y1, which is 3, and then square it. All right, and then once we do that, we're just going to go ahead and simplify. What we're going to have to do here,
You're gonna have to add them.
we're going to add those together. So that's going to turn to 2 plus 3 squared plus -2 subtract 3. And if you want to, you could skip steps as long as you do it right. 2 plus 3 is 5, so that's going to be 5 squared, plus -2 minus 3 is -5. And if negative numbers, you put them in parentheses, but so that you don't forget, just always put your numbers in parentheses when you're squaring.
Yeah.
5 squared is 25. -5 squared, if you do it with parentheses in your calculator, you would get +25. If you don't use parentheses, which is wrong, you will wrongfully get -25. And that's why you want to use parentheses. All right, so 25 plus 25 is square root 50. And in order to find that in your calculator, when you do it, you have to do square root of 50.0. All right, and does anyone have the answer for what the square root of 50.0 will be? Remember, if you don't put 0.0, your calculator is going to do what we were doing before. It's going to split this up into square root 25 times square root 2, and then give you this as an answer. So you got to make sure you put a decimal if you want to have a decimal answer. And when you look at number 2, they have decimal answers.
Is it 7.07?
Okay, you get approximately 7.07. And when you look at your answer selection, it asks you to round to the nearest tenth. The nearest tenth is this point right here, the 0. And so if you look to the digit to the right of that, that 7 will change the 0 up to a 1, so 7.1. All right, and so that is your answer. And which selection is that?
That is C.
C. All right, so that would be choice C. And that's how you do that. Let's try another distance question. And that would be, let's just try number 13 on the next page over, on page 104. All right, anyone still copying this here?
Let's try to do it by ourselves.
Yes, I was going to ask you guys do that. So go ahead and try to do number 13. Those who are finished. Is everyone else finished copying this?
Yes.
Or leave it up because I have a feeling somebody is still copying it. So I see an answer there, 3.2 as a selection, and I haven't had the opportunity to even check. So I'm gonna do that real fast and go over it. You guys can help me with how to do it. Has anyone memorized the formula yet? How would I write out the formula? D is equal to what?
The formula is
And even if you read it, it's fine.
distance equal to x squared.
X2. So we say X sub 2 or just X2?
X2 minus X1 square
X1.
plus Y2 minus Y1 square.
Right, and all of that, the square root. Okay, and so for this one, they gave us the points. -2, -5, and 3. -3, sorry. -3, -8. So a lot of negatives in here, so you got to be really careful how you substitute. And remember also, you want to label them. However you want to label them, just be consistent. So, X1, Y1, X2, Y2. All right, so how would what number would I write first if we chose this method, the way that I wrote it out?
-2, -3.
Okay, so you did just since you're reading it out, I'm gonna change it to how you wrote it. So you wrote yours as X2, Y2, X1, Y1. All right, so you said -2 minus -3.
Minus, yeah, negative then squared.
Right.
Plus -5, -8, then squared.
Right. And what happens in the inside?
I have a 1. No, okay, I have 1 squared plus 3.
Right,
squared.
-2 plus 3, because remember, this is for anyone else who may not have seen it. Let me just circle these in a different color. Did I erase anything? These will turn positive, and that's how she's getting 1 there.
Oh, no.
All right, so -2 plus 3 gives us the 1, and that's how we get the 1 squared. Okay, what else?
And then 3 squared.
Right, -5 plus 8 is what gives us +3. All right, and then what?
And then I have 1 square root 1 plus 9, which is 10.
And that gives us square root 10. And in order to put that in your calculator, don't forget the decimal. And what does that give us?
My calculator was not giving me right, but I kind of get 3.2.
Yep, that's what Latavia had said in the beginning. That is correct, 3.2. And that's how you did a distance formula. Now, they will combine it sometimes. So if you look at number 9 could have an A-B type scenario. You could have number 9 and you do that. And then the next question might ask you, what is the distance between P and R? And you would have to look there and decide what the points are. So you have to look there and say P is -4, 0, and R is 0, -2. And then you have to find the distance between the 2 points, right? Anything could pop up that tests your ability of understanding. And that's why we were practicing how to read those points, because you're going to be asked scenarios like that. All right, 7:35. All right, how do you guys feel about the distance formula? Is it making more sense?
Yes, sir.
All right, so we're going to have to move on from here. I would just suggest whatever we did not finish, just, add that to the homework. So we didn't do like number 1, we didn't do number 8, and we didn't do a few of the numbers between 12 and 15. So try to knock those out over the weekend, but we're gonna move on. I'm gonna push you guys, you're really doing well there. So turn the page on the workbook, sorry. So turn the workbook over to page 106. And I'm really pushing the envelope, but remember, the key is to just go back and practice. And I'm gonna pick a few problems out of here, but you're gonna add this to your homework. Remember, I thought I had an extra week, and so that's one reason why I'm really pushing now, and hopefully you like that. You was copying that, George? I just happened to see you look up and then write something. Your mic is muted, George. Okay, George, can you hear me? Your mic is muted. And I can't unmute you. It won't let me do it. So just give me a thumbs up
Okay.
if you got it. Did you get everything?
Yeah, I'm getting everything. Which page are we supposed to open?
106 on the
Which page?
workbook. We're just going to continue right on.
Okay, 106. Thank you.
You're welcome. All right. And then next week, we're going to touch on geometry. So we'll be finishing up with this. I go pretty detailed. All right. Let's see. Now, they touch on stuff that we've already done, right? So if you look at the top of 106, the workbook and the student book don't seem to go hand in hand. They seem to be on another level. But anyway, they already have the slope formula that you see there. M is equal to y2 minus y1 over x2, take away x1. We talked about that like on Tuesday or last week. But then they talk about something called the slope-intercept form. I briefly mentioned that to you, which is y equals to mx plus b, where m represents the slope and b represents the y-intercept. Now, you might be asking yourself, what is intercept? Does anyone watch football? You ever heard of the term interception? Well,
Yes.
interception means, you know, you're kind of cutting off the path of the ball, and therefore you intercept it from its intended point. So it basically means to intersect something. That's another way you could say it. Intercept, intersect, right? So the y-intercept literally just means where does it touch the y-axis? Where is it crossing the y-axis? If you go back, if you turn your page back to page 105, and you look at number 17, sorry, not number 17, number 18. Remember we found 150 was the starting point? That is the y-intercept. The y-intercept always has a value where your x is 0, and then your y value represents the b. Now, the b just means any number. We could use any letter. It could be c, x, y, whatever. But we're just saying b to stand out. So the b just means that it's crossing the y-intercept. So that, if you look at number 18, what we were doing on page 105, our y-intercept was the point 0, 150. So 150 was the y-intercept. Now notice, this equation is not in the same form as number 18. Number 18, the y and the x are on the same side. On this equation, the equation has been solved for y, and they call this slope-intercept form. Now, the reason why we use it a lot, it makes it easy to graph without a table. And I'm going to show you how in a second. So once again, it's called slope-intercept form. The slope is always next to the x value, like we just did in a few problems, and the random number that's by itself. If they mix up the order, sometimes they do that to throw you off. They might write it like this, right? This is the slope, not the x, sorry. The m is the slope, remember. And the constant is the y-intercept. And normally I do a lot of stuff to kind of practice that, but we don't have that luxury. So just to kind of go over that real fast with you, if we had y equals to 3x plus 5, then my slope is 3 and my y-intercept is 5. Does everybody see that?
Okay.
Slope is 3 because it's next to the x, and the y-intercept is 5 because it's by itself. If I change it around and I had it in a weird order, like y equals to -6 and then minus 4x, then what is my slope? My slope is whatever next to the x, including the sign. So my slope would be -4, and my y-intercept would be 6. Now remember, slope is rise over run. So if we got a whole number, we just put it, every whole number can be written as a fraction as over 1. And so that's how you can use your slope. If you have a whole number or an integer, just put it over 1. And there you have your rise over run. Does that make sense?
Yes, sir.
All right, you may, if you're feeling behind, you definitely want to watch this one here on YouTube. Now, if we actually, I just want to show you the connection. If you look at number 18 again, number 18 on page 105, I just want to show you the connection of the slope-intercept form with the other form. The other form, we call it standard form. And that's when we have it, the X and the Y's are together. We call this one standard form. And then we call the other one, sometimes you might hear it as Y-intercept, but generally it's called slope-intercept form. And so those are the two different ways to write the equation. I want to show you how you can relate to them. If we took number 18 on page 105, where our Y-intercept was what? Do you guys remember what the Y-intercept was? Where did it touch the revenue? Expenses, sorry. Where did the expenses touch the Y-axis?
At
150?
150.
At 150. So what you would do, when it's in this form, you don't need the 0. You just need the Y part. And so that's plus 150 because it's a positive 150. You have Y equals to something. You don't know what your slope is yet, but you could count your slope if you need it. If you looked at where 150 is to, let's just say, we might not get it right on the money, but I think it's going to be pretty close. If you count up, actually, I'll just make it work. Let me see. Was it C was our answer? And then that's 15. That's up 50 and over 80. So we're going to say that's 180. So if you look at the intersection right there, right? Let's just say that was the intersection and that was 150. We're going to say that the intersection was at 180 and that it touched down here at 15. And so this was 0. If I needed to find out my slope of the expenses, make sure you're looking at 105 and you can do this with me. And I know I drew it a little bit different, but I hope you can follow along. The 150 is the Y-intercept for my expenses. And if I count it to the next point, which we found out, we changed it to 180. If I count it up 30 units, right, that's going to be my rise. So my rise is 30. And then my run, if I went over, would be 15. Does everybody see how I did that? If you look at the chart, we went up 30 and then across to where they intersected. That's 15. If we reduce that, we get 2x. 30 divided by 15 is just 2. And so you end up with 2x plus 150. Now that is the slope-intercept form. All I did was find the slope between 150 and where it intersected. And you can do that on your own. If you look at 150 and where they intersected, we're going to use 180 as the line, and I worked backwards to figure that out, but it was 180. Now look what happens if I solve to make sure the 150 is by itself. If I wanted to make that 150 by itself, I could bring the 150 over on one side. That would cancel. I have y subtract 150 equals to 2x. And then I could bring the y over. And if I do that, you see I have negative 150 equals to 2x subtract y. And that's the exact same equation that we chose for number 18. Did everyone see that connection? I know that might have been a bit of a step there, but once again, all we did, we took that equation, y equals to mx plus b. We looked at that graph. Remember, m represents the slope. Remember, the slope of the line is the rise over the run. And I'm letting you know that where this intersection is, where the expenses and the revenue intersected, we count up 30 units. And then on where the pounds are, we counted over 15. And so rise over run would give me 30 over 15. 30 over 15 is the same as 2. 30 divided by 15 is 2. And this would be our form in slope-intercept form. But if I wanted to change it into standard form, I could solve for, in a sense, 150. and I'll bring the 150 over, etc. What we do in regular algebra, and we get the exact same equation that we chose for number 18. And so slope-intercept form is just another method of setting up an equation. Now it's actually much easier than you think. And we're gonna do that with number 1 and 2. And I'm pretty sure number 1 and 2 will make you feel better if you were lost here. So turn to page 106, and you're gonna see how easy y equals to mx plus b slope-intercept form is. So the first thing, number 1, is everybody there? This is gonna make you feel better.
Yeah.
What is the slope of number 1? What is the slope of line G? So if you look above, you see line G, you see 2 points that they're trying to help you to find. What would that slope be?
That would be, let me see,
So
1
first,
over 2.
say that again.
1 over 2, I guess.
1 over 2. Okay, looks like you just counted the easy one. So if you do your rise over run, she counted to where the y-intercept was. So if you count 1 unit up and 2 units over, it takes you right to that point 2 where the line's crossing. And so your slope there would have been a half. And which choice is that for number 1?
That's D.
D. Now look how easy y-intercept is. Remember, the B represents where it crosses the y-axis. So if I was to write this out, remember m is the slope. My equation for number 2, can anyone figure out what that would be? Okay. Well, y would be equal to, what was my m?
M is a half.
It's a half, so instead of mx, I'm gonna write half x, I'm substituting,
Right.
plus b. Remember, b is where the line crosses the y-axis. Where does it cross the y-axis? At what number?
At 2.
And we're done. That's slope-intercept form. Y equals to half x plus 2. Which answer would that be?
That's C.
That's C. All right, so that would have been C for number 2, and then number 1 would be D. And if you go back with the homework and you try that with number 9, you can see that you can find the equations for number 9 by doing the slope-intercept form. And try it. That's what you could try for homework. We did number 9 using our understanding of slope, but you can now add into there trying to use the y-intercept as well, and you see it's actually much easier doing the slope-intercept form. All right, let's try another one. Let's look at number 7. Number 7, we're going to try to write the equation of the line in slope-intercept form. And everyone try it. See if you can get it. Don't just sit there and wait for me. If you're trying it at home, no one knows if you get it right or not anyway, so you must as well try it and see if you can get it before me. And you can even be there in the quiet saying, yes, I got it, right? I don't know if you are, but it would be really good for you if you are doing that. So number 7, look at that chart. What kind of slope does it have? Is that a positive slope or a negative slope?
Positive.
That's a negative slope.
That's negative. Think about from left to right. What would be happening if you went left to right? You'd be skiing downhill, right? So that's a negative slope. So already, if you look at number 7, what are your only possible answers there?
A and B.
A or B. It has to be A or B, right? So let's actually use the graph. If you start at any point, it doesn't matter what point you choose, you want to try to get what the slope is. So count to see what your slope is. What would be the slope of that line, the actual value? We know it's negative, but we need the actual value of that negative number. So negative what?
It's a 5.
5.
Well, if you count from that first point down to the second point, you're going to have to count down. And when you count down, that makes it negative. And how far are you counting down? Where are you counting to? Are you counting to the y-intercept? Or are you counting to the other point?
You come to the
So-
X.
X.
So the X,
To what x?
negative.
Negative 4.
Negative x.
Are we on number 7?
2 over 5, negative 2 over 5 x.
Okay, how are you getting negative 2 over 5?
Because of the rise over run.
And I'm
From,
assuming you're going to the y-intercept. That's what it looks like you're doing. So
okay.
whoever, so if you count down here, that would be negative 2, you're going down. And then if you count over, that's positive 5. And so that gives you negative 2 over 5. X, remember it's y equals to mx plus b. And then where is it crossing? What is the value of the y-intercept?
3.
3. So that's plus 3, and you're done. That's the equation of the line. Does that make sense?
Yeah.
All right, let's try number 8. If you look at number 8, that one's a real life question there. And, oh, my battery's about to die. See if you could do number 8. Number 8's a word problem, so you have to read it carefully. I'll read it out to you now that my computer's plugged in. Number 8 says, Andrea paid an initial fee of $20 to set up her cell phone. Now she pays $30 per month for service. The amount she pays for cell phone service for a certain number of months can be graphed in the first quadrant of a coordinate grid. What is the equation of the line? Now, the beauty of this one, sometimes they give it to you as a word problem, and you have to set it up like we did in the past, right? They might give you questions like that too. But this one is, we're blessed because they give you a graph, which means you can actually count it. So looking at the graph on number 8 on page 107, can you figure out what your y-intercept is and what your slope is? Remember, that's all you need to write a number, an equation in slope-intercept form. You have your slope and your y-intercept. Remember, your slope is always next to the x.
Y-intercept. The y-intercept is 20.
Okay, so if it's 20, then which answers must it be? It has to be either what?
And B.
A or D. It has to be A or D. So now we just need to make sure we choose the right slope. So count your slope, but notice how the y's are counting. Are they counting by 1s, 5s, 10s, 2s?
10s.
10s.
So be careful when you count up. Remember, it's rise over run. So it's how you count up or down. Remember, counting down is negative. Counting to the left is negative. So rise over run. How do you count up to the next point? How much do you go up?
30.
30.
By 10.
So you get 30 over something. 30 over what?
1.
30 over
Over
1. And
one.
what does 30 over 1 equal to?
30.
30. So that's
30.
x plus 20. So y equals to 30x plus 20. Which choice is that?
D.
D. Do you see how easy slope-intercept form is? Now, like I said, sometimes they might ask you to rewrite it into the other form, right? Sometimes what you see is that what we saw on that revenue question, number 18, sometimes written in that format. And that tests your algebra skills. Sometimes they give it to you in that form, and they ask for your slope or your y-intercept, which means you have to use your algebra to write it back into that format. And that's where I say, basically, you just need to know the basics, and then they're going to ask you everything about the basics. It's like a car, right? You learn where your stick, if you're learning where your gear select shift is, you learn where your gas and your brake pedal is, your wheel, your indicators, and then they send you out on the road. And anything can pop up, but it's based off of your basic knowledge. And this is the basic knowledge. You know how to solve, you know how to use fractions and decimals, you know how to use your calculator. We learn how to pinpoint points on a graph. We know how the x and y correspond with each other. We can substitute in there and then use our understanding of solving. And now we've learned how to read an equation just by looking at the line. Is that starting to make sense?
Yeah,
I think you guys are getting it. That's why I'm pushing you. If you weren't answering me, I would have said, all right, next topic. But the fact that I'm getting you guys give me the right answers, that's why you see me saying, all right, next lesson. All right, so it really, what time is it? 7:56. So we're gonna stop there. And that's what you wanna try for homework. If you really wanna push yourself, you can, and you can try to do the next lesson. But for now, what you can do is just finish 102 to 109. And if you really push yourself and you make the time to do this, you will see you understand this in leaps and bounds. And right when we log off, I didn't put it up because if I don't do it right away, my children come in and then I forget to do it. I'm gonna do the YouTube videos right now before I let them in. And so you should see them, however long my internet takes to upload it, you should see all the videos pop up from the last one, and you can catch up this one if you need to rewatch it. All right? If there are no other questions, then we will pick up on Tuesday. And Tuesday, we'll just do like one more review, and then I'm gonna show you how to use the geometry section. Geometry, like I said, all you need to know to do well in geometry is to know your shapes and to know how to identify the formula on the formula sheet and how to substitute. If you can do that, you've got geometry down. It's all about just, geometry has a list of formulas, and they're gonna say, find the area of the circle. And then you find the formula for the area of circle, and you substitute the stuff in. They say, find the area of a sphere. And a sphere is like a ball, like a soccer ball, a basketball. And you just get the radius, they tell you what everything is, and then you find the formula on the formula sheet, and you substitute the values in, right? If all else fails, substitute. All right, so that's where we're gonna end. Dorcas, I see your hand up.
Yeah, Mr. Ray, I don't know if you gonna review. Do you have a review questions for us? Like what we've learned from the beginning, like each of the,
So
I don't know.
what I'm gonna do is, well, we're supposed to get you guys a GED voucher, so hopefully we'll have it on Tuesday. That's the best review I, in my honest opinion, is to just try to do the reviews. If you have an extra $6, then you can do it again. The key is to really just practice that. And also in your student book. In the student book, at the end of each unit is a unit review. There are 4 unit reviews altogether. And my suggestion is to do the 4 unit reviews and also to do the practice test. Now, I haven't been pushing this because they kind of threw 2 classes on me. Some of you might have been in the class. I'm teaching, I picked up a science class because the teacher had resigned. And so that's one reason why the YouTube videos don't go up as much, because I haven't done science in a while and I had to kind of relearn some of the topics. And so I've been kind of overwhelmed with that part. But what you want to do is in the student book, at the end of each unit, you'll see the unit review. Try to do that like a test. Try to do unit 1 like a test, and then grade yourself at the end. Try not to get in the habit of working it out, looking at the back, working out, looking back, because then you're training your brain to always have an answer whenever you start a problem. And then you'll never really be able to get through the test. Try to do as best as you can. You could possibly choose about 10 questions every so often, or every 15, or if you want to, try to do all the questions first and then grade yourself. But try not to get in the habit of, all right, let me see the back. All right, let me start. Now let me see the back. Right? You will not prep yourself correctly for a test that way.
Yeah, that's true.
All right, so remember, once again, the unit review on the student book is how you can help with that. And also on Apex Learning, I haven't really been pushing that. Like I said, I've been kind of swamped with picking up the 2 science classes. And then the GED, My Ready. So I'll try to have a voucher for you guys next week, but if you don't mind sparing $6 to do it on your own as well, I would suggest that as well. That way you get used to the actual program and how to find the drop-down menu for the formulas, how the click and drag works. It's good to do that. All right? Yes.
Thank you.
I know you said you were going to upload the videos. Just a reminder, because on the weekend I have a little more extra time to go over some of this stuff. So,
I'm gonna do that right now, because what I said on Tuesday I meant to do it, but like I said, if I don't do it by the time my children come in, it's like over. So
Thank you, Mr. Ray.
instead of letting them come in, I'm gonna do it right now. Because once
Thank
it
you.
starts the process, it just loads up.
Thank you.
Yeah, you're welcome.
All right, thank you, Mr. Ray.
All right, you're welcome. Enjoy the rest of your evening, you guys.
Thank you. We'll talk to you
You're
Thank you,
Tuesday.
sir. Bye.
All right, bye-bye.
Thank you, Mr. Ray. Good night.
You're welcome. You as well, Jacob.
Thank you, Mr. Ray.
You're welcome, Marisol and Salvador, Dorcas, and George.
Thank you, Mr. Ray.
You guys all have a good evening.
Thank you.
You're welcome.
Thank you.